All right. In the interest of, once again, eliminating distractions, I've found somebody to invite who does not talk. So, here is my new best friend. He's a polar bear. And I'm going to use him like a guard dog, except a bear, obviously. Can you move over to that side? All right. Scoot. Somewhere. Yeah, that'd work. All right, so assuming that he'll do his job and eat anybody who tries to distract us, we can get started on prisms and pyramids. So on a sticky note here, I'm going to write the basic formula. If we need the volume of a prism, it's just going to be the area of the base, which we're going to use a capital B for because these formulas like to make it confusing, times the height. So this is area of base. I put area in all caps because most people get messed up. This is one of those problems, one of those lessons in math where the wording is confusing. Because not only does the capital B stand for area, which is like it should say A, right? But also, base doesn't always mean what base would mean in real life. Okay, so before we use that, let's look at the volume of a pyramid also. And it's similar. It is, in fact, the exact same formula, but split into thirds. Okay? So if you had an imaginary prism that the pyramid fit inside perfectly, the pyramid takes up a third of the space that the whole prism would. So that's what volume means. It's the amount of space something takes up. And so we'll use both of those formulas. And the trick is we need to know what base are we talking about. So in a prism and in a pyramid, sort of, it's a memory trick. It's going to take a little imagination. But basically the base is the part that matches. And it's really hard for a memory trick because base sounds like bottom, which is what we're used to in real life. In real life, if this were a structure that were built, the bottom there, that rectangle on the bottom, would be the base. But that's not how prisms work. So I guess maybe the best way to think of it is both. B for both. And so here, this rectangle down on the bottom, it does not have a twin. There's no both with that rectangle. So I know that cannot be the base. Now here it even gives me words that'll help. Triangular prism. The name of the prism is always going to give you a clue as to the base. So the triangles are for sure the base, and it makes sense with my definition of both because here's the one triangle and, excuse me, bear. Here's the other triangle. I got both triangles, so those are the base. Now again, I don't just look at that and use it, I find the area of it. So it's like a math problem inside a math problem. Put in here, use formula. And so a pyramid, it's the same thing except the top base is invisible. Okay? So the bases, you have to have both of them, except in a pyramid, you only see one of them. And this is normal. The pyramids almost always are sitting on their base. It's almost always the bottom. But if you can imagine that this went straight up and had a floating square above it that touched the tip of that pyramid, that's the base. And I mention that because the wording will help you again. The type of pyramid it is naming the base. This is a square base, and it comes to a point here, so the top square doesn't exist, it's not visible, but that's the idea. It's a way to try to help you to find the base. Really, I've never seen somebody struggle finding the base on a pyramid, but on the prism, it's hard. So remember, B stands for both matching shapes, and we need to find the area. So we'll try that here. We got a triangle, And so I need to know the area formula for a triangle. If you don't know this, it should be on your reference sheet. If you don't know this and have to look on your reference sheet, go ahead and memorize it, because it's better to know it than to have to go find it and then use it and find it and remember it while you're writing it down. It's so much easier to remember. Okay? It's 1/2 the base of the triangle, so this I'm going to write a little b, times the height of the triangle. And so really, if mathematicians made sense with their formulas, they would call this a capital H. And I know it's not written that way on your formula sheet, so I didn't write it that way originally, but this is the height of the entire prism. Height connects, I'm not going to fit that on there, base to base. And so right away I know the height for the whole prism is going to be that. I'm not there yet. All I'm trying to do is find the capital B part of this formula, which is the area of the base, which here is an A, but if we want, we could turn it into a B. This is the capital B we're looking for. Okay? So you've got two choices. You can plug those numbers in right now, find B, and then use that and plug it in later. Or the sneaky move I like to use is, now that I know what that means, go ahead and replace it right now into the formula. So I know the volume of a prism equals capital B. Wait a minute. I know what capital B is. This capital B is the same thing as this, so I'll say capital B, but I'll write 1/2 base times height, and I'm talking about this base and this height, times, again, if I make this a capital H in the formula, the height of the whole thing. So this can get confusing. It makes the math nice by the end, but you've got these different heights, and there's not a right way to do this. If you like to solve this and then use it later, that might be the easiest for you. If you don't have a problem remembering, oh, this height is that height and this height is that height, go for it. Whatever works for you on these problems works for you on these problems. Okay? So right now, I'm going to deal with this over here, and then we'll replace it there. I've got 1/2 times 12. This is only dealing with the base, and it's only trying to find the area of the base, not the whole entire prism. So 1/2 times 12 times the height of, again, just the base. That's 8. Now I'm going to be sneaky here. 1/2 of 8 is 4, and 4 times 12 is 48. So B equals 48. That was all this here. So the volume equals 48 times, and then the height of the whole thing is 34. Now, 48 times 34, I'll rewrite it down below so I can do some multiplication. 4 times 8 is hopefully 32, unless I've forgotten a great deal of math. 4 times 4 is 16, plus 3 is 19. I used up the 4, so I'm done with that place. Underneath the 3, 3 times 8 is 24. Write the 2 up here, write the 4 down there. 3 times 4 is 12, plus 2 is 14. And then 2 plus nothing is 2, 13, carry the 1, 6, 1, and I don't suppose you know how to circle H for me there, do you, Mr. Polar Bear? Excuse me. All right. So, there's the formula. Kind of a pain, and the best way to make it not so much of a pain anymore is to practice it a whole bunch. The more you practice, the more you know, oh yeah, I write this, but it means that, and this means that, and that means that. If I explain it to you the first time, it makes probably 0 sense. If you do it carefully, the first 3 times, it's a pain. 4th, 5th time, it's annoying. 6th, 7th time, yeah, it's not so bad. The more you do it, the easier it gets, the less of a pain it is, because you just get used to it. Okay. So down here, I know the formula is 1/3 of area of the base times the height of the whole entire pyramid. So here it says the height of the pyramid is 7.5 meters. I can write the formula right now. The volume is going to equal 1/3 times, I'll leave that blank, that's the area of the base, times the height. Area of the base here, well, this is a square pyramid, and one side is 9, so with a square I know I just multiply that by itself. I've got 1/3 of 81 times 7.5. Now, if you know your factors, then this is a pretty easy one to split up and reduce and blah, blah, blah. This is actually going to be 27. 1/3 of 81 is 27. I can do that in my head because I have it memorized. If you don't have it memorized, don't do it in your head. Just write it out. 1/3 times 81. You could just divide 81 by 3. It's probably the easiest way. You could also do fraction multiplication. 1/3 of 81. Make sure you write 81 as a fraction. If you do, then by the end, you got to turn it into long division anyway. 3 goes into 8 2 different times. That uses up 6 of those. 2 are left over. I carry down the 1. 3 goes into 21 7 times. Told you. And then I'm multiplying that by 7.5, so I'll write that there. 5 times 7 is 35. Carry the 3. 5 times 2 is 10, plus 3 is 13. And then I'm done with the 5, so I'm done with that space below the 5. Below the 7, 7 times 7 is maybe 49. It's a little early in the morning. I'm not sure about my math just yet. And let's see if this works out. Oh, right. I had in the problem one number to the right of the decimal. So I need one number to the right of the decimal. 202.5. Boop, 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 boop. Done. So that's pretty much all we do. And you'll notice this wonderful little polar bear did not interrupt me once. Amazing. I'd give you a high five, but I'm worried you'd scratch me. So let me grab the next paper we're going to work on. And we'll keep our little sticky note with all my formulas right there. These are different shapes, sort of. This is still a prism, and so even though the shape of the prism changed, triangular prism, rectangular prism, the formulas don't. And that is the one nice thing about these formulas. They're so generic, they work for everything. The only thing I need to do is figure out what thing is the base, and then use that to get the area of the base. So here it says, a ring-tossed toy is composed of a rectangular prism on top of a cylinder. The rectangular prism is completely filled with water. The dimensions of the rectangular prism are shown in the diagram. A little bit 2, that's the depth. 15 is the height. 9 is the width, if you're describing it as you would like in a normal conversation. What we say in math is, okay, the bottom and top are the base. Except with a rectangle, you really don't have to say it that way. Any of those rectangular sides can be the base. That's what's crazy about rectangles and rectangular prisms. But for the sake of being at least a little like real life, we're going to call the top and the bottom the base. So I need the area of that rectangle, and the area of any rectangle just equals length times width, or base times height of a rectangle. That gets confusing though, because then the rectangle has a base and a height, and the whole entire prism has a base and height, so let's just say length times width today. So that's 18, and because this is my base, the area of that base is also my capital B in the formula. So I've got the volume equals capital B times the height, and again, this is the height of the whole entire prism. So that's going to be the line that connects base to base. It's going to be 15 here. So I have 18 boop, boop, times 15, boop, boop, and I'm going to get a headache if I try to do this in my head. Unless I'm sneaky. And let's face it, I am. 18 is the same as 9 times 2. 15 is the same as 3 times 5. And this really doesn't look so bad. 2 times 3 is 6. 6 times 5 is 30. 30 times 9, well, that's just 3 times 9 with a 0 on the end. Boom. So, again, you don't have to do it in your head. If you're not used to doing it in your head, you shouldn't do it in your head. But if you want to be a super mathlete, you are welcome to use that factorization multiplication trick. Makes it easier to do big numbers multiplied in your head. Pretty cool. This top problem, if I can scoot it. Okay, I can only scoot it so far. Something in the shape of a triangular pyramid has a height of 6 inches. The area of the the base of the speaker is 11 square inches. Wait a minute. Did they just make our life easy? They sure did. They told us the area of the base. So when I write that volume formula, volume equals area of base times height, well, suddenly, magically, I don't have to do math to get this one letter. It tells me right there that number is 11. The area of the base, it says right here, if you could read it. Trust me, it says the area of the base is 11. And it says the height is 6, so I'm pretty much already done. 66, and it's under there somewhere, and we'll just move on. All right, you're getting a little pushy, Mr. Polar Bear, but honestly, it's still less distracting than my mother. Those puns were unbearable. No, I didn't mean unbearable like you can't be here unbearable. No. Polar Bear, come back. No, you're helpful. You're really helpful, but no. Oh. I lose all my good help. Poor Surfer Dave. Poor Polar Bear. All right, kids. I unintentionally offended my new best friend, and I'll go see if I can find him and make it up to him. But you can solve these while I do that.